Hi everyone, I am Maximiliane Windl from the University of Regensburg, and today I present you our work on the implementation and in situ assessment of contextual privacy policies. A big part of our lives happens online. Now more than ever. We shop, chat with friends and share our most personal moments. While we do that, a huge amount of data is generated, which is used for many different purposes, like the personalization of ads or content. This becomes a problem when this data is leaked and abused for criminal offenses. Therefore, it is very important for users to know what happens to the data, how it is protected, and which options are available for users to control the usage and collection of their data. The most established, and actually also pretty much the only way, to inform users about their rights and choices concerning their privacy are privacy policies. That long text, which is mostly hidden somewhere, and which describes which data is collected and what is done with it. That sounds sensible, but there's a problem. Almost nobody reads them. According to a study by Obar from 2016, around 74% of all users don't read privacy policies at all. And those that do read privacy policies take on average 73 seconds to read a whole privacy policy, which has on average a length of 2,700 words. That would mean a reading speed of 37 words per second. That's pretty fast, right? Why is that? In general, users are interested in what happens to their data, but oftentimes users' actions don't match their intention. This phenomenon is called the privacy paradox. In the case of privacy policies, the main problems are their length, the difficult legal language in which they are written, that they are often hidden somewhere at the end of a page, and that it's often hard for users to make a connection between the abstract wording of a privacy policy and their actual behavior. In the past, researchers have suggested several approaches to improve privacy policies and to evolve them from a purely textual representation. Kelly et al. Transferred privacy policies to the format of nutrition labels. Craner et al. Built a browser extension which points out aspects of the privacy policy depending on user preferences. Tsai et al. Added privacy information to search results. And contextual privacy policies, which are also the focus of our work. They were first proposed in 2004 by Lederer et al. They remedy important shortcomings of privacy policies by splitting them up and displaying only relevant parts directly in the context of the current user. A first controlled evaluation of CPPs with users was conducted by Ortloff et al. In 2018. Due to several reasons, none of the existing approaches is currently adopted in praxis. Contextual privacy policies seem to be among the most promising ideas, but they are not implemented so far. So we do not know whether users accept them and whether they really help users understand the implications of privacy policies. We implemented contextual privacy policies as a browser extension for 7 of the most popular websites in Germany. Those are Google, Facebook, YouTube, Twitter, eBay, Amazon, and eBay Kleinanzeigen. We extracted relevant information and situations from privacy policies from those websites and defined suitable action triggers. Here you can see the CPPs in action. As soon as the user enters the query, the CPP box is displayed informing the users about the kinds of data collected in this exact moment and this exact context. Here the context is searching for something on Google. We evaluated CPPs by installing them on the participants' computers for 1 week. During this time, they were instructed to keep on using their browsers as usual. To get an impression of the participants' behavior, we did pre- and post-study interviews and also collected data through the extension. These data were automatic logs, a timestamp when a CPP info was displayed, and the number of appearances. Additional feedback, which could be given at any time by clicking the extension's icon in the browser's toolbar, and diary entries, which were collected through a pop-up window, which appeared at most once every hour. In this diary entry, the users were asked for benefits of the provided privacy information, if and how this information will affect their behavior, and to rate the relevance of the information. In total, we had 15 participants which provided valid data. 8 of those were male, 7 were female. We used a thematic analysis approach as described by Brown and Clark to analyze our interview data. We first transcribed the interviews, then followed several rounds of coding the utterances, did discussions to resolve any differences in the coding, and finally grouped the codes into categories. This resulted in 2 large groups: utterances about data in the widest sense of the word, and utterances about the CPPs themselves. Each of those groups has 2 categories. For the first group, utterances about data, these categories were data collection, with the subcategories approval, disapproval, and neutral, and behavior, with the subcategories change, no change, and current behavior. The second group, utterances about CPPs, had the categories consideration for future use, with the subcategories novelty of information and feature requests, and additional feedback, with the subcategories feedback on the text and feedback on the look. Due to our mainly qualitative approach and the small number of participants, we were not able to make any further statistically significant claims. However, some interesting tendencies emerged from the data nevertheless. We measured how participants assess the relevance of a given CPP information concerning the site, the situation, and the participant. Interestingly, the largest amount of variance was measured between participants, which leads us to believe that the assessed relevance of a privacy information mainly depends on personal opinions. How concerned users are about their data in general, and whether they see a benefit in the collection of their data or not. Through the analysis of our qualitative data, we found that participants assessed the CPP information less relevant the more often they were confronted with it. This intuitively makes sense, so we checked whether we can see the same trend in the quantitative data. But there was no clear tendency. The assessed relevance decreases until day 4, but after that it is fluctuating. The problem is that not all participants saw CPPs every day, and as seen in the previous plot, relevance ratings varied a lot between participants. For some participants, there was a decrease in relevance over time, but for some, there wasn't. Our study allows for design suggestions for the further development of CPPs or similar systems. These are: keeping novelties important for the relevance of privacy information. Users want a way to comprehend the information of the privacy policy faster and more easily. The phrasing of the privacy policy should be adjusted to the person reading it. People need help on how to adjust their behavior, and people being okay with the data being collected strongly depends on personal assessments, so CPP should be adaptable. To summarize our contribution, we developed contextual privacy policies, which provide privacy information in a shorter, clearer structure and within context. We implemented a system to display CPPs in a naturalistic environment. We showed that users prefer CPPs over traditional policies. We provide feedback and design suggestions for further development of CPPs and similar systems. And we also provide the code for the system on GitHub. Thank you very much for listening and your interest in our work.